Okay, welcome back. This is part two of the 11.4 notes. We're gonna find the area of regular polygons and composite figures. So let's start with this. Now remember that you're given a couple of different, we have a couple different measurements from this. So what I know is that this is my radius. I know this is my side length, and I know that this is this. Oh dear. The perpendicular length from here to here is my apothem. Okay. Now you're given the radius. Okay, radius is 10 centimeters. Okay. Now we also know that the number of sides in this figure. This is a pentagon. We've got 1, 2, 3, 4, 5. So n is equal to 5. Okay. So I'm going to use the formula because we're given r. I'm going to use the formula um, my area is equal to r squared times the number of sides times sine of 360 divided by n all over 2. Okay, so my area here is going to be, let's just plug these values in. Now I've got 10 squared times 5 times sine of 360 divided by 5, and I'm going to divide that by 2. Okay, so let's go to our calculator and plug this in. And so let's take a look and see what we get here. I'm going to do alpha y equals to give me a fraction. Okay, and I'm going to do 10 squared times 5 times sine of 360 divided by 5, close that, and then I'm going to move to my denominator and divide that by 2, and I'm just going to hit enter, okay? And this is going to give me 237.8 centimeters squared, okay? So this area is 237.8 centimeters squared. So again, all you really need to do is use the right formula, plug these numbers into the formula, and hit enter. Okay, now if you're doing this and you don't have the fraction capability in your calculator, make sure you put your numerator in parentheses and your denominator in parentheses and just divide this from that. And you should get that. So that's something to play around with. If you're not getting 237.8, then kind of use this, try and play around with it until you get that. All right. Now let's take a look at this. All right. Now this is an octagon. Okay. This has 1, 2, 3, 4, 5, 6, 7, 8 sides. So I know that that my number of sides n is equal to 8. All right. Now I'm given a side length. Now if I call this my center, this is my apothem, this value here is my radius, this forms a right angle, this is my side length s. So I know that my side length here is equal to 15 inches. All right. So let's use, so if you're given the side length, you want to use the formula that area is equal to the side length squared times the number of sides divided by 4 times tangent of 180 divided by the number of sides. So 180 divided by n. Okay. So now let's just plug that in. And so we're going to get that area is equal to 15 squared times the number of sides, which is 8. And I'm going to divide that by 4 times tangent of 180 divided by 8. All right. So if I go to my calculator, I'm going to do, and I'll do it the other way. I'll do it using parentheses. I'm going to do parentheses, okay, 15 squared times 8, close my parenthesis. Okay, this is my numerator. Now I'm going to divide that by my entire denominator. So I got to put parentheses around that, and I'm going to do 4 times tangent of 180, and crap. No, I don't need a parenthesis there. I'm going to divide that by 8, close my parenthesis for tangent, and then I want to close my parenthesis for the denominator. Okay, so I have a big parenthesis for my entire denominator. Let's go ahead and hit enter here, and I'm going to get 1086.4. Okay, so I get an area of approximately 1086.4 inches squared. Okay, all right, so just use your formulas, plug and chug, guys. All right. Now the next one are composite figures. Now the composite figures, you can kind of consider them just like irregular shapes. Okay, irregular. All right. And so, I don't have a specific formula for this figure here. But what I notice about this figure is that I've got two different figures that make one figure. I have a rectangle and I have a triangle. Okay, so if I wanted the total area, then I would take the area of the rectangle and I would add the area of the triangle. Okay, so now and so if I just take the area here and I know the area here, then I can just add those two areas together and get the total area. Now this area is pretty easy, 5 times 12, but my question is here, what is my height of this triangle? Okay, and so you kind of have to use the picture to kind of give you that information. This is a right angle here. This is my height. Now, if the entire length here is 20, and I know this length is 5, then I know my height is just 20 minus 5 to give me 15 meters. So let's calculate our area here. All right, so if I take the area of the rectangle, so area is equal to 5 times 12, base times height, so I get 5 times 12 plus the area of my triangle, which is 1/2 times the base. Now my base length is 12 meters. Okay, that's that length here, same length over here. So I take 12 times 15. All right, so now I get that my area, my total area, is 60 plus half of 12 is 6 times 15. So we end up getting that our area is 60 plus, okay, 6 times 15 is 90. All right, and so then our area here is going to be 150 meters squared. Okay, so again, you want to break these shapes up into smaller shapes that you can calculate the area and then just add them together. All right, let's take a look at the last one. Now this one, whoa, this one's pretty crazy. All right, now I don't have a specific formula for this. All right, I just don't. Now what I do notice is that I have a base and a height here. And if I were to calculate the area using that base and height, I would calculate this entire area here. So what I have here is I have actually a square, and then I have a half circle. Okay? And I know that my radius, my diameter here is 8. I know that my radius here is going to equal 4, because it's just half the diameter. So this is kind of interesting. Now, if I wanted, and we're going to call this the shaded region. Okay, this is my shaded region. So if I wanted the area of my shaded region, area of shaded, that's going to equal the area of my rectangle or square. Okay, we'll call it the rectangle. Rectangle is a square, but not every square is a rectangle. The area of the square minus the half circle. Okay, so I can take the total area and subtract out the area of this half circle, and that leaves me with the remaining area. So let's write this out. So I've got my area is equal to the area of the rectangle, which is 8 times 8, okay, minus the area of a half circle. Now watch what I do here. I'm going to do pi times my radius squared, but because it's a half circle, I'm going to divide that by 2, okay? So then I have my area is equal to 64 minus pi times my radius, which is 4 squared over 2. So I get this. I get my area is equal to 64 minus 16 times pi divided by 2. Now I can divide 16 and 2 out, and I get that 64 minus 8 pi. Now this would be an exact area. Okay, but we can plug this into our calculator and we can get an approximation. And if we do that, End up getting 38.9, and these are inches squared. Did I get a label on this one? Yeah, I did. Meters. Okay, so these are composite figures. So again, you want to find the smaller, the shapes that you know you can calculate the area of, and either add or subtract those out. Okay, so I hope you enjoyed this. This is a pretty fun section. Please get started on your homework.